Hi everyone, and welcome to this video on applications to maximum and minimum problems. Yes, I did read it. Thank you very much for watching. Hopefully it's going to be helpful. My name is Darren from Maths Guru. You're going to say, where? My little corner of the internet where you can sign up and get all these videos and downloadable lesson notes and a general maths summary book and more coming over time. Now, if you can do me a massive favor and subscribe to my YouTube channel, it's great. It's massive. It just tells me that you've watched it. Because, I mean, in all seriousness, who watches math videos? Not like I'm ever going to go viral, is it? Now, behind me are the learning objectives, and we're going to understand how to apply all of the previous theory to maximum and minimum problems. Now, to be honest with you, there are a certain number of questions that I think we use over and over again. And I'm not going to say this video is exhaustive, but the process by which you solve the questions, I have to say, is almost like a recipe. But we'll come back to that in just a moment. So I'm going to work through a number of questions and hopefully give you the tips and tricks on how to apply it to your own working that's coming up. Right, recap of past learning. Now, as I say, this is really going to go back over the idea of tangents and normals and rates of change and stationary points and types of stationary points and all that stuff as well, but with a real world focus. And there are real world maximum and minimum application problems that we use all the time. Okay, so let's look at example number one. A loop of string of length 100 centimeters is formed into a rectangle. Find the maximum area of this rectangle. Now, whenever I see these type of questions, I highlight what it is they're trying to get me to find. And in this situation, it is the area. Okay, so, well, I don't know any dimensions. Nope. And so, interestingly, what I tend to do now is I draw a very quick sketch of what it is I'm looking for. Now, there is a rectangle. I need to find the area, which means I need to know a length and the width. But I don't know the length and the width. Okay? And a lot of people turn around and go, well, can't I just call them X and X? Well, that's a very specific type of rectangle, but we want something a little bit more general. So what I'm actually going to do is say, whereas in previous parts of the course, maybe we just use one pronumeral, there is nothing wrong here to finding two or to using two pronumerals. All right, okay. And again, this whole idea of a loop of string or fences backing onto a bush or a fence, all these type of stuff is so typical. We use it ever such a lot because it really does trick people. Right, there's the area. So what I'm now going to do is say, well, my area is equal to xy. And because the most important part here is the word maximum, the minute I see the word maximum or sometimes minimum, I know it's got to be differentiation. Okay. Now, the problem with differentiation, or if you remember, at the moment, we've got two pronumerals. We cannot currently differentiate this without getting it to just have one pronumeral. It can either be x's or it can be y's. Now, obviously, we get so used to having x's. Wouldn't it be great if there was a way of actually getting that y and sort of substituting it out and putting an x in its place? Now, yes, admittedly, I could delete it and put an x in the place, but that's not what I'm doing. So what other information has the question given me? A length of 100 centimeters. Well, what's that telling me is if I add this value and this value and this value and this value together, what do I get? My perimeter. They're actually telling you in code the perimeter. So I now know that my perimeter, which we know is 2x plus 2y, my perimeter is 100 equals 2x plus 2y, or x plus y is equal to 50. Now you're going to say, but why have you done that? Generally speaking, these questions will give you something where you have an equation in two unknowns and some way of rearranging or getting rid of one of those unknowns. Now, because I've got a y here, I can now rearrange that and give me y is equal to 50 minus x. Do you see what I'm going to do now? That basically means that wherever I see a y, I can now replace it with 50 minus x. So I now know my a becomes x, 50 minus x. If I multiply that out, I get 50x minus x squared. And now I've got an area formula in terms of just one pronumeral. Now I can do dA by dx. That is differentiating my area with respect to x. And to do this will allow me to find my maximum. Why? Because what do we know about maximum and minimums? The gradient of the tangent at that point is equal to 0. Okay, so I'm going to differentiate. That's going to give me 50 minus 2x. We know that at a maximum, we're going to get 0 is equal to 50 minus 2x. So 2x equals 50, or x is equal to 25. Okay, Now, what does that tell us? That x be equal to 25. Okay, so that is when we are going to have our maximum area, which effectively is going to be a square. Right, so what does it say? Find the maximum area of this rectangle. Well, now the maximum area, so therefore our maximum area is going to be x times y. So we're going to go back to my original formula here. Okay, that's going to be x times y. I know that x now is 25 times, oh, what's my y value? Well, actually, I think we can pretty much work it out, can't we? Because that's 25 and that's 25. We know the total distance all the way around is 100. So that's 25 and 50. Well, y must also be 25 and 25. Now, don't get me wrong. There are many of you out there who will already have gone, but I know it's a square. It's just 25 and write down 25. Sadly, not the point of methods. To be honest with you, in many cases, the correct answer is irrelevant. It is your working out to get from the beginning to the end that is where your marks will come from. Now, this may have been a 4-mark question. If you just wrote down 25, you will be lucky to get 1 mark out of those 4. You don't get the method marks, the working out marks, if you're not showing the thought process. And methods is all about showing your algebra. But again, there are tricks to doing this. This is fairly formulaic. Right, so y must be 25. And 25 times 25, he says, firing up my calculator off screen because you can't see it. Some of you may know that, 625. So my maximum area is going to be 625 watt, though, because we don't, excuse me, want to forget our units in any of this. And so our units are going to be in centimeters and squared. There we go. So that is my maximum area. So area max maybe, or something along those lines. But pretty much that is what is important to be able to work out this question.